If we want to find the limit of a sequence which is given to us by n cubed over e to n, when n is greater or equal to 1, we write down the corresponding function, x cubed over e to x, and then we take limit of a corresponding function when x is now approaching infinity. E to infinity is infinity, x is approaching infinity, so x cubed is going to be also infinity, so we have infinity over infinity, and we are allowed to use L'Hopital rule. Derivative of x cubed is 3x squared, derivative of e to x is e to x. We try to substitute infinity for x one more time. We're going to get 3 times infinity squared is infinity on top. E to infinity is infinity again, so we have infinity over infinity. So we do L'Hopital rule one more time. So we take limit as x approaching infinity. Derivative of 3x squared is 6x. Derivative of e to x is e to x. So we apply L'Hopital rule one more time. So we're going to get 6 times infinity is infinity. E to infinity is infinity. So we have infinity over infinity. So we do L'Hopital rule one more time. Derivative of 6x is 6. Derivative e to x is e to x. Take limit of that expression as x approaching infinity. 6 is a 6, e to infinity is infinity, and 6 over infinity is 0. So we conclude that limit over function equals to 0, therefore limit as n approaching infinity over corresponding sequence equals to 0. If we want to find the limit over sequence sine of pi n, if we try to switch to corresponding function, we're going to get sine of pi x. We take limit of this function as x approaching infinity, and we're going to get sine of pi x. So we're going to get sine of infinity, and sine of infinity does not exist because function sine is going up and down, up and down, up and down, oscillates between -1 and 1, so sine of infinity does not exist. But here we have to slow down. If limit of a function of a corresponding function when x approaching infinity does not exist, it does not mean that the limit of a sequence will not necessarily be not existent. So in our case, let's investigate a little bit further and see what's actually happening. When n equals to 0, we're going to get b of 0 is sine of 0, which is 0. When n equals to 1, we're going to get b of 1 equals to sine of pi, which is 0. Just in general, for any n, bn, which is sine of pi n, is going to be 0. So our sequence actually is going to look like first one is 0, second one is 0, third one is 0. So it's going to be consistent of bunches of zeros, 0, 0, 0, 0. So obviously the limit of a sequence which consists of 0, 0, 0 is going to be 0. So the limit equals to 0. So to summarize, often, sometimes, it happens that limit of a function does not exist. It does not necessarily mean that corresponding limit of sequence does not exist. It might be happening that limit over sequence still exists. If we want to find the limit of a sequence which is 3 plus 5 n squared over 4 minus n squared when n is bigger or equal to 3, we'll take limit of that sequence. And in this case, I will try to do a rule of thumb. So what the rule of thumb tells us, if we have a rational-like equation, then higher power dominates. So if you look at the top, we have 5n squared and 3. 5n squared is so much bigger than 3, what will just be as good as 5n squared. On the bottom, we have 4 minus n squared. N squared is so much bigger than 4 that we might just think about the bottom as just n squared. And now we take limit of that new expression. We apply algebra to cancel n squared. So we're going to get a final answer is -5. So that's how we're going to be applying the rule of thumb to find limits. If we're looking for a limit of a sequence, which is given to us by expression n plus sine n over 3 plus 2n, when n is greater or equal than 0, we try to take limit of that expression, and we run into problem with that because we have sine of infinity, which does not exist. So what I'll do in this case is we'll say n plus sine n over 3 plus 2n is between, sine is at most 1, so n plus 1 over 3 plus 2n. Sine is at least negative 1, so n minus 1 over 3 plus 2n. So now we take limit of expression on the left. If we take limit of expression on the left, it is using the rule of thumb that is n over 2 to n, because n minus 1 is good as n, and 3 plus 2n is good as 2n, so we have 2 over 2 to n. So the limit of that sequence on the left when n is approaching infinity is going to be 1/2, because n and 2 and n will be cancelled out. Now if we look at the right side, we'll do similar calculations. That limit of that expression is going to be the same as, you're using the rule of thumb, as n over 2n, because n plus 1 is good as n, and 3 plus 2n is good as n, 2n, and we cancel, so that is, when n is approaching infinity, also 1/2. So in both of these cases, left and right side, they're both approaching 1/2, so we're sequence in the middle, try to wiggle in between, but it's going to be squeezed and becomes 1/2. So therefore, the limit over expression in the middle, limit of expression in the middle is also must be equal to 1/2. So it wiggles, 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 but becomes also 1/2. One more thing which I wanted to mention is the following. Here we have a sequence, and an is increasing, and also there exists L, number L, such that an is less than L for every n. Then let's consider what is happening in this case. So let's consider what is happening in this case. So we have L, which is put an upper bound on our sequence. So sequence cannot go above that line. So what is happening? We have sequence which is increasing. It's going up, 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 up. So the sequence has only two possibilities. So if it's increasing, it can go all the way up and shoot toward infinity, or it should stabilize because it cannot oscillate up and down because we have n is increasing. So because it cannot shoot toward infinity, so it should stabilize at some point. So what you conclude from here is, if the sequence is increasing and bounded from above, therefore it should converge. Therefore the limit of that sequence should exist. So then limit of n and s and n approaching infinity exists. Or we say an bigger equal than 0 is convergent.